Hi, this is Evgeny. Today we'll go into make an auction app with WebSockets. Yes, turns out that you can do something besides chat application with WebSockets and many other things. But today we're going to do that. Let's look what it's going to look like in the end. So we can bid on an item that is under auction, and many people can participate. Every person who's participating will get real-time price updates. They will also see how much time is left for the auction until it ends. So just like in a real life auction, they can also join later and get all the updates and still participate until the auction is done. And when it's done, it shows who it was sold to and for how much, and you can't participate and bid anymore. So I'm going to do it in FastAPI. Let's start. First, we're going to create requirements.txt in which we put all the necessary requirements and make a fast boilerplate application for FastAPI. Check that it works. Go and make a database. I'll be using SQLModel. And if you don't know what is happening here, you can look at my in-depth video about how to create a database with SQLModel. You can also use SQL Alchemy or whatever you want. So our item will have a bidder. It will have a name of the item itself, description, the minimum price, price tab, which is something, the smallest amount by which the price can be incremented, completed or not, and start and end time. Okay, now let's import the models and create our database. Okay, now we'll get our database file and let's start with our WebSockets. We'll create a connection manager which will manage, well, from its name you can understand that it will manage a connection. It will connect, disconnect, and send messages to the connected people. Our connections will be a dictionary of WebSockets. So let's say we have a room in which the auction, for each auctioning item there will be a separate room, and the room will be represented by a number in our database, and auction connection will keep the number of a room, and it will contain a list of participants, which is a WebSocket. So connected method will check if auction room already exists, and if it doesn't, it will create a list with that auction number, an empty list with the key of that auction room, and it will add the participant to that room when connecting. Disconnect will just remove a participant from that list. Okay, now broadcast method will send messages to every person who is connected to some room. We will have two kind of broadcast messages. It can be just text information, and it can be information about the price update, and it will be sent as JSON. Since WebSockets are synchronous by nature, we use the async await syntax while dealing with them. Okay, now let's create the endpoint for our auction WebSocket. They're generally made with WS in the URL, and it's also asynchronous. So first we'll connect the participant, and let's create session that will let us manipulate the data in our database. Our WebSocket connection is wrapped in while true, so it works until the participant disconnects. We will get our item based on the room in the auction room which we joined, and retrieve the information from it. If step or current bit aren't set, then we'll assume it's 0, and we will calculate minimum new bit to check if the new bit is larger than the previous one. So we will make checkups. If new bit is not set, we won't do anything. If participant is the same, if new bidder is the same as the previous one, we're also not doing anything. And new bit should be larger than the current one. Then, if the minimum price is smaller than new bit, and new bit is larger than minimum required, then we can set the new one, update the time at which the auction finishes, and commit it to database. After that, we will broadcast to all participants that the new bid has been set and the new price and new auction ending time is set. Now let's wrap it and try except to handle disconnects and notify if a participant left the auction. Okay, now let's populate our database with some data. We'll just use random and pretend that we're selling paintings. It will have item and description and all other fields that our auction item model has. Don't forget to return the instance of auction model, just like I forgot here. After that, we can add and commit it to our database and create it. And also, I forgot to set the default value for start date. After that, we check and our database is done. Okay, let's address a couple of screw-ups that we had. Since we can have multiple auctions, we actually need to broadcast to a specific auction. So we will need that. We will pass auction ID as required field to our broadcast. And as we can see, the typing isn't quite correct as well, so we'll fix that. And now let's send to our broadcast. Let's send auction ID that we already have in the method. And it is fixed now. Okay, let's try test our backend now and see if it works. So we have application running, and let's go to a console of your web browser. We'll create a new socket on the console and address the URL that we set. And as you can see, the connection has opened. Now let's add the listener for our WebSocket so we can also see the information that backend sends to our site. We can do it with on message like that. And now let's try to send a new bit. For it we'll use WSSend, and it works fine, and we got all our information from backend, and listener also works, so our backend works. Congrats. So that's it for the first video, and we've covered most of the backend. I decided to split the video into two parts in case some people aren't interested in the front end. On front end, we just need to send bit-in data to our WebSocket and display what we receive. And I will be posting front end part shortly after this video. And I will be using Svelte library for it. So subscribe if you want to see it, and leave a like if you found the video interesting. I'll leave to this code in the description of the video. So thanks for watching.